All right, so let's talk about how to solve these multiple leg journey problems. Oh, hey, check this out. Look at that. It's upside down. Wow. That's what I get for taking apart my setup between things. There we go. So here we go. Multi-leg journey problems. Okay, so let's just say that for some reason you are traveling to school and you are going to you're going to walk. You're going to walk for 1 kilometer, and for some reason you're going to do it at um, let's use kilometers per hour as our standard here, and so you're going to walk at 2 kilometers per hour. I know these are non-standard units, but we'll keep everything in kilometers an hour, okay? But then you get picked up and you get a ride in a car, and you get to go this last 2 kilometers to school, and you're going to do that in, let's see, 2 kilometers, a little over a mile, so that's going to take you about 0.2 hours. Okay, now this is crazy because we know that what we need to do to find the average velocity is that we need to find the total displacement or distance traveled and divide it by the total time. Well, that's going to be a little difficult. The total displacement is pretty easy to do here. 1 kilometer plus 2 kilometers is 3 kilometers. But we can't add up the total time because we have 0.2 hours, but we have a speed here. We have a velocity. So the way I find that's easiest to do, the way I find that's easiest to do, what the heck does that mean? The thing I think is easiest to do is to create a table. And on the table, you're going to have the leg of the journey. You're going to have the displacement for that leg. You're going to have the time for that leg, and you're going to have the velocity for that leg. And you're going to have, let's go ahead and make this a solid line. There we go. So leg number one, leg number two, and we're also going to have a row for the total. And what's going to happen here is we're going to use the equation velocity equals displacement divided by time. We're going to use it for the totals over here. That's going to be this thing and this thing. So let me put a dotted line around this and this thing. Those two things are important. They're going to go over here into this recipe. But we can also use this across any row to figure out missing information. So we walked 1 kilometer, and I'll put kilometers in there. And then we did it at 2 kilometers per hour. So we can use this equation to find this missing piece. And then we got to ride in a car for 2 kilometers, and that took a time of 0.2 hours. And we could use this to find out how fast we were going. So let's go ahead and do that. If you're going to find the time is going to be the displacement divided by the velocity. You can check that out with symbolic algebra if you don't believe me, but it's displacement 1, let's put the calculator over here so you can see it, 1 divided by velocity, which is 2, and that took us half of an hour, so we can go 0.5 hour. And then here, if we want to find this velocity, it's just displacement divided by time, so we can go 2 kilometers divided by 0.2 hours, and we get 10 kilometers per hour. And now we can add things up. 1 plus 2 is 3 kilometers. 0.5 plus 0.2 is 0.7 hours. And 2 plus 10, well, you don't do that. You don't add these velocities because you don't really need this. This is not necessary, nor does it make sense to just add velocities. So let's go ahead and use this recipe here, total displacement divided by total time, to find the average. Here we go. 3 kilometers divided by 0.7 hours. And your average velocity for this was 3 divided by 0.7 equals 4.285. Okay, let's just call that 4.3 kilometers per hour. That's your average velocity. And you see that's between 2 and 10. It's a little closer to 2 than it is to 10, and that's because you spent more time walking than you did riding in the car. So this is how to solve it. Make a table, use this equation, this basic relationship, to fill out any missing information, then add up the total displacement and time and put those in the average velocity formula. So let's do another one. Let's add one where something strange happens, okay? Let's do a journey where you do 4 kilometers at a speed of 10 kilometers per hour, then you stop for 0.25 hours, that's 15 minutes, and then you do 20 kilometers per hour for half an hour. Okay, that's a three-leg journey, three different things, and let's make a table out of it. Delta X, T, and V. Leg 1, 2, 3, and the total. And remember, we don't want this one. We just want these two right here. Okay, so leg number 1, 4 kilometers at 10 kilometers per hour, then stopped for 0.25 hours. That's a speed of 0 and 0.25 hours. And then 20 kilometers per hour, you see the units tell me what category to put it in, and 0.5 hours. Okay, so now that I've got that, let's go ahead and use the formula, the basic formula that velocity is displacement divided by time. That would also mean that displacement is velocity times time. That would mean that time is displacement divided by velocity. See, that's monkeying this formula around all three ways. Okay, so up here we need time, and that's going to be displacement 4 divided by velocity 10, and I got 0.4. This is hours, and this is kilometers. And then we got to do the next one. The next one, we're looking for displacement, so that's velocity times time, 0.25 times 0. You are forgiven if you didn't do that because it's pretty clear when you multiply these, you're going to get 0 kilometers. It's also pretty clear that when you're stopped, you are not having any displacement happen. And then finally, we need the displacement again. So now we need the velocity, 20 times 0.5, that would be 10 kilometers. So for a grand total of 14 kilometers here, and a grand total of, oh my, okay. 0.5, 0.4 is 0.9, plus 0.25, 1.15 hours. Okay, sure. Oh, this looks like Christmas now. That's great. So let's see. We need to get the average velocity, which is, of course, the total distance traveled divided by the total time. There's no shortcut to this. You have to do that. Total distance traveled is 14 kilometers, and the total time is 1.15 hours. And we'll use the calculator for that. 14 divided by 1.15 is, what is that? 12.17. Let's call it 12.2. I only had single digits here, but I had 2 digits in other places. I should probably just keep 2 digits, but I kept 3. It's not out of control. I would accept 12 here. That's what we're doing with sig figs here. So this is how to solve these kinds of problems. They're not that difficult, but you really need an organizing principle, and you get to use this little formula a number of times and practice with it, okay? Keep in mind that these times that we're traveling 4 kilometers at 10 kilometers per hour, we're not accelerating during these times. There would be acceleration as you transferred from leg 1 to leg 2. You would decelerate or slow down, and then from leg 2 to leg 3 you would accelerate. But those are small pieces. We're just looking at the velocity here. So these aren't acceleration problems. Okay, that's all I wanted to say about that.